Today we are going to solve a question from the chapter continuity and differentiability. So we are given with the two functions f of x and g of x. Both are defined from R to R. So and in a third function h is defined from R to R such that h of x is a maximum of f comma g when x less than or equal to 0 and minimum of f comma g when x is greater than 0. So how to solve this question? The first thing is to know about f of x and g of x. So for that, let us draw the graph of f of x. So our function f of x is mod x plus 1. So this is the graph of mod x, and the mod x plus 1 graph will be like this. Okay, so I'm just drawing mod x plus 1 graph first. So this is mod x plus 1, and this point is 0, 1. I hope that you all know this graph. It's very easy. So this is the graph of mod x plus 1. Now next function is g of x, which is x square plus 1. So x square plus 1 graph, we know this is the graph of x square. X square plus 1 graph will be like this. This is 0, 1. Now we need to draw these two graphs together. These two graphs I should draw together. So how it will be? So we have these two graphs. I'm going to draw it together. This is mod x plus 1, and this will be x square plus 1. Okay, this point is 0, 1, and this point will be, this is very easy. If you want, you can do like this: x greater than 0, you take both the curves. One is x square plus 1 and the other is mod x plus 1. When x is greater than 0, mod x plus 1 is x plus 1. Equate them, you can see that x can be either 0 or x can be x square equal to x. So x will be 0 or 1. Okay, so point of intersection is 0, 0 and 1, 2. Okay, so that's how you can get this point of intersection. Now left side, it's very easy to predict because both are even functions. So this will be minus 1, 2. So this is the graph. Okay, now what we are supposed to do? We need to take its maximum. Now in the question they have said that h of x equal to maximum of f of x comma g of x when x is less than or equal to 0. So we should consider the case of f of x less than 0. So this is our portion, f of x less than 0, left side. Okay, so when you take left side, maximum of f of x comma g of x is needed. So when x is less than or equal to minus 1, it is clear that maximum of f of x comma g of x, this is your g of x and this is f of x. So which is maximum? G of x is maximum because g of x is above f of x. Then your h of x will be g of x. Now who is g of x? G of x is x square plus 1. So that we got. Okay, now minus 1 to minus 1 less than x less than 0, less than or equal to 0. When you look at that case, which is larger, f of x or g of x is larger? It is clear that f of x, that is mod x plus 1, is above x square plus 1. So maximum of h of x, f of x comma g of x means the graph which lies above this portion I am talking about. Okay, above will be the function. So minus 1 to 0, who is above? Red graph, that is mod x plus 1 is above. So our function will be f of x, which is mod x plus 1. Okay, now mod x plus 1, if I want, I can write it as minus x plus 1 because x is less than 0. Okay, Now, so that part is done. When x is less than or equal to 0, it is done. Now, similarly, same, if we consider right side, if I take 0 less than x less than or equal to 1, we need minimum of f of x comma g of x. So who is minimum? Minimum is that black graph, which is x square plus 1. Okay, so we will get x square plus 1. When x is greater than 1, we need minimum. What is the minimum? Which is the minimum? Red one or black one? It is red. So red means mod x plus 1. So this is the entire function. Now let me write this specifically. H of x is equal to x square plus 1. When x less than or equal to minus 1, then minus 1 to 0, it is mod x plus 1. Mod x is minus x plus 1. Then 0 to 1, the function is x square plus 1, and x greater than 1, it is x plus 1, mod x plus 1. So it's very easy actually. These steps are not required. If you are good enough, you can directly write this one directly. Okay, this part, final definition of h of x, you can write directly. Now what you are supposed to do, draw the graph. If you want, you can draw the graph. Already we have the graph. So left side we need maximum. Maximum means this will come. Then let me use the color so that you will have more clarity. This one. Then you need a minimum. Minimum means x square plus 1. Then you need again minimum. So this is the graph. This is x plus 1. This is, okay, there is a small problem with this graph. Okay, so this is the graph. Okay, so this is x square plus 1. This is minus x plus 1. This is x square plus 1. Now it is clear that there is sharp edge. We have doubt at certain points which are minus 1 and 0 and 1. We have doubt because function is continuous everywhere. Now we need to check whether it is differentiable. Okay, now it is clear that there is sharp edge at 1 and sharp edge at minus 1. So function will not be differentiable, not differentiable at 1 comma minus 1. Now what about 0? 0 also it is clear that there is sharp edge. Okay, so function is not differentiable at these 3 points. Now if you want to know it specifically, you can differentiate the function piecewisely, and then also you can check. This is 2x when x less than minus 1. Do not include equality because we don't know whether it is differentiable or not. Okay, so this is minus, again you will get 2x, 0 less than x less than 1, and 1 when x greater than 1. Now you can see that in the left side of minus 1, left hand derivative will be 0. H dash 0 minus is h dash 1 minus. H dash minus 1 minus. Left hand derivative at minus 1 will be 2 into minus 1, which will be minus 2. Okay. Now right hand derivative at minus 1 plus will be, you need to take the right side, which is minus 1. So at minus 1, LHD not equal to RHD. So non-differentiable at minus 1. Similarly, at 0 also you can find LHD and RHD, which will be different. And 1 also LHD and RHD will be different. At 0, LHD will be minus 1, RHD will be 0, non-differentiable. At 1, LHD will be 2, and RHD will be 1. So non-differentiable. So that's how we can prove this. Okay. Thank you.